of 2k squared. In fact, I think you guys had one of these for homework, right? With a divisibility. It almost looked like the same sort of thing. Except we're trying to show divisibility by 2, okay? What do you guys think? Yeah, multiply it out. We'll get 4k squared. Sweet. So that equals 4k squared, okay, by multiplication. And then factor, and how would you factor that? Like 1/2 times 8?
Not 2.
2 times 2. I was just trying to be a smartass.
You could do it that way, it wouldn't help.
I could, but it would not help. You are absolutely right, Mr. Weber. Alright, it'd be completely fruitless for me to do it that way. Okay. So yeah, we could just factor off the 2 and get 2 times 2k squared. Okay, that's just by factoring. Computation, multiplication, whatever. And guys, what do we know about 2k squared? Some integer. Let's call it m. Did you say m too? Wow. That's crazy. Are you
Great
mind
minds think
reading?
alike, yeah.
Bro, no, I'm not a great mind.
Not with that attitude.
Ouch. I've got spirit, yes I do. Alright. So guys, that's by closure, right? And clearly what we've shown is that the contrapositive is true, okay? So, this is by closure. Okay. And what we can say is that thus, n squared is equal to 2m, and is even by definition of even. Which means that the contrapositive is true. Okay, so thus the contrapositive is true. Which means what?
The original statement is
The
true.
original statement must be true as well. They're logically equivalent.
So,
So thus the contrapositive is true, which means the original statement must be true. Thus, the original statement must be true as well. Okay? Or we just say must be true. Easy enough, right guys? Okay? Go ahead, Brian and then Greg.
And why couldn't we have done the original?
Because unfortunately, okay, that's a good question. Okay, so let me let everybody copy that down. But if we wanted to just use a direct proof, right, we would say that, what was it, if n, we said if n is an element of I, right? N squared. Oh, no, we said if n squared is in Zi, then n, right, okay. Now, this means that n would have to just be any integer, right? So unfortunately, if we try to do this, we could set n squared equal to 3, right? But it's not a perfect square, okay? So unfortunately, we don't have a definition for a square root that we can utilize, okay? We just don't have that operation going on. So the only way that we know how to work with this is just the contraposition method. Does that make sense? Just because of the square root operator, right?
I was wondering, when we did the substitution step here, why did we only take the step for the n squared? Is that because it's the only one that matters?
Oh, right, because we're trying to prove that n squared was even. Right?
Right.
Because remember, when you do the contrapositive, we said if n is even, then n squared must be even as well. Okay? Does that make sense now?
So you only care about that n squared?
Oh yeah, we only care about the then. We're only trying to prove the predicate, not the antecedent. Alright, other questions, guys? Okay. I could do the other one for you guys, but what I think we want to do is, I'm just going to go ahead and work this out and post it on Blackboard for you guys. I think most people would be pretty good with doing that, okay? But it's basically just like a divisibility proof. Plus I need to get back your assignments, so. Any questions, guys, about anything that we did with either contraposition or contradiction? Okay, so let me give you guys back your assignments. Okay, if you guys have some questions for me, I'd be happy to stick around and answer those questions for y'all.